Enthalpy. So enthalpy is energy is given off or absorbed per 1 mole. So in this case, you're going to have to utilize the mole ratio in order for you to calculate the real amount of energy that is being absorbed or being released from a certain chemical reaction. So let's go ahead and look at the first chemical reaction. So you have to know that this one is actually methane reacts with oxygen, and that it gives off carbon dioxide plus water, and that is the enthalpy, which is the energy changed in a chemical reaction, which is negative 890.4 kilojoules per mole. That's what we were talking about. So negative side means it is an exothermic reactions, and any combustion will be an exothermic reactions. So now, since we are dealing with the mole ratio, so we're gonna have to interpret how many moles of methane are reacting with the oxygen gas. So 1 mole of methane reacts with 2 moles of oxygen gas to produce 1 mole of carbon dioxide gas plus 2 moles of water in the liquid form. So there are 2 different ways that the question can be asked. First, how much energy is given up when 5 moles of methane are burned? It's very easy. So you're gonna have to use what it is from the chemical reaction. So basically 1 mole of methane produced is giving up how much is that? So I'm just gonna say 1 mole CH4 released kilojoules. So 5 moles of this methane we released, basically it's 5 times, and that gives you how much? You're gonna have to use calculators. It's this much. So that would give you 4,452 kilojoules per mole. So for the second equation, so how much energy is released when 32 grams of methane are burned? So first we're gonna have to convert grams to mole. So it would be 32 grams of CH4 multiplied by 1 mole. The molar mass of this one, which is 16 grams. This is actually converted into 2 moles of CH4. So So 1 mole of CH4 produce how much? 890.4 kilojoules per mole. So if you have 2 moles, so go ahead and multiply this one by kilojoules per 1 mole. So basically that would give you 2 times of that. It would be 890.4 times 2, and that gives us about kilojoules. So now we're going to move on to the second part of the lessons, which is his formations. Enthalpy of reaction. These are the formula. So the enthalpy of the whole reaction is equal to the product minus reactants. Remember, coefficient play important roles in this case. So I'm going to explain by using an example. So we're gonna have to figure out, first we're gonna have to look at the table here, which is called standard enthalpy. This table is given to you. All you have to do is just be able to interpret what information is given. And now we are tasked to calculate the enthalpy of, reaction of 3H2 reacts with oxygens, produced 3 moles of waters in the gas. So basically, if you are given information like the standard enthalpy of individual substance, when you use this formula, you should be able to calculate and confirm with the number is given in the certain chemical reactions. So the formula says the product. So I'm just going to say delta H of reactions is a product. How many products do we have in this case? We only have one. Remember, it would be this. Minus the reactants. How many reactants do we have? We have 2. So now I'm just going to replace the standard enthalpy for water, which is negative 222, subtract from the formation of the reactants. 3 times 0 because the pure substance is 0. All you have to do, all you have to memorize is hydrogen and oxygen gas will always be 0. But this case is not oxygen gas, it's ozone. So that should give you this 33. So now you just add the math, do the math. Three times 242. Give you negative that. Negative. So you're gonna have to add those 2 values. So this is the values from our calculations. So basically this is an exothermic reaction because of that. Go back real quick. So one of the last one that we need to understand is the Hess law, which is you actually have to combine this chemical reaction in such a way that it will match that one, the one you desire. Hint, if you flip equation, the side flipped. If you multiply by coefficient, you also multiply by the amount. So look over here. So from the equation 2, so what I can do is, how many mole of oxygen, carbon dioxide gas do I need to have? 1 mole. So that's actually being good. So I'm just gonna say that these equations stay. So in order for me to cancel this one out, I need to make sure that the equations are right. So we're gonna resume Hess law for the next video.